we're going to take a quick look at 0 and negative exponents. Now, 0 and negative exponents, we just kind of call out separately because they can get a little confusing. One of the first-ish things that you're going to be shown with this is they'll usually throw something like this up at you. They'll say b to the 0 is 1, as long as b itself is not equal to 0. You're like, oh, okay, like I totally know what that means. Basically, the idea of this is if you have any power raised to the 0, like if I have 3 to the 0, or 5 to the 0, or 9 to the 0, or pi to the 0, or bug to the 0, they're all equal to 1. And you're like, that sounds like some hippie math stuff. And you're like, well, okay. So there's actually a reason behind this if you really, really want to know. It's an application of that quotient rule thing. So let's say that I had 3 cubed, I don't know, that's weird. Let's say I had 3 squared over 3 squared. All right, so one way you could work it out is you could say, well, that's 9 divided by 9, and 9 divided by 9 is 1, right? Well, another way you could solve it, if you were being super nerdy and obnoxious, is you could say, well, this is a quotient rule problem. So that means that I have 3 to the 2 minus 2, right? Because I have a 2 on the top and a 2 on the bottom. So 3 to the 2 minus 2. That's 3 to the 0. And that looks like a 6. That's 3 to the 0. And I don't know what 3 to 0 is. So I have to work it out the other way. Oh, 3 to the 0 must be equal to 1. Sort of. All right. You believe me or you don't. There's not much I can do at this point. If you don't want to understand them, or don't desperately don't want to look at this anymore, that's okay. You can just accept it. But it's actually kind of cool that it does work out that way. And it's a consequence-ish of the quotient rule. Now, of course, if you have a 0 to the 0, then we're not going to mess with that. We just don't want 0 to the anything. I think 0 to 0 is actually 0, but we'll leave it at that. Anything to the 0 basically is 1. All right, so that's your 0 exponents. Now for the negative exponents, what we're going to have on there is that, come here, what we're going to have for that is that b to the negative exponent is equal to 1 over b to the exponent. All right, and again, that's kind of a consequence of the, rule, of the quotient rule, except I'm going to work it backwards. So let's pretend I had 1 to the 3 squared. All right. So you're going to love this. All right, so we know that 1 is 3 to the 0 over 3 squared. Yeah, it is. So I have 1 over 3 to the 0 over 3 squared, and so I can say that's 3 to the 0 minus 2. So that's 3 to the negative 2. All right, that's amazing, right? Yes, you love it. No, that's all right. But basically the idea is that if I have a negative sign on the exponent, I can flip it and throw it into the denominator of the fraction, and then I'm totally good to go. All right, and again, there's like this b cannot be equal to 0 thing, so you can't divide by 0. But I always forget that because, it only comes up, I mean, probabilistically speaking, b should never be 0 because you have an infinite number of other choices to pick, but it doesn't matter. Anyway, point being, so I have 1 over 3 squared is the same thing as 3 to the negative 2. And usually we work at the opposite direction. So I would be given 3 to the negative 2, and I go, oh, that's 1 over 3 squared, or 1/9. I just did it, I think it at least derives better in this direction, but we usually see it applied the other way. So really that's about the worst that you can see. Now what you don't want to confuse is you're going to love this. Let's pretend I had negative 3 to the negative 2 power, all right? So just so you can kind of see all the permutations of this. So I've got negative 3 to the negative 2. So that's 1 over negative 3 squared, all right? Which still technically is 9, so you get the same answer. Let's pick one that you wouldn't get the same answer for. Let's give you, let's do 2 to the 5th. So we've got 2 to the negative 5, all right? 2 to the negative 5 is going to be 1 over 2 to the 5th. And we worked this out in a previous video, but just in case you need to know, 2 times 2 times 2 times 2 times 2 is 4 times 4 times 2, which is 16 times 2, which is 32. All right? So 1 over 2 to the 5th would be 1 over 32. Right? As opposed to just 2 to the 5th, which would be straight up 32. So to make sure that you kind of understand where we can go with this, if I have negative 2 to the 5th, remember, well, we did this in another video, but basically the idea is I've got some negatives on here. 2 negatives make a positive, 2 negatives make a positive, but this guy's still negative. Positive, positive makes a positive, positive, negative makes a negative. So we have negative 2 to the 5th is still negative 32. But if I wanted to be super obnoxious, I could do negative 2 to the negative 5. That would be 1 over negative 2 to the 5th. And negative 2 to the 5th is negative 32. So basically negative 1 over 32. So those are the only things that they can do to mess with you. But again, the idea is, what I'm trying to get you to see is that this negative sign here is totally different than this negative sign here, okay? So those negatives and the other negatives, the negatives in the base and the negatives in the exponent, have to be dealt with totally separately, okay? So this is something I recommend, kind of pulling these 4 out and just putting them on a piece of paper, and every once in a while kind of going back to them and making sure that you can get the correct answer every time until you really have it solid in your mind. Basically, that if you have the negative in the exponent, you flip it to the bottom. If you have the negative in the base, that means you've got to apply that. If they're odd, then it's negative. If it's even, then it's positive, and that kind of thing. All right? All right. This is just a little fun. You can also apply it backwards. So we kind of did, if I have 1 over, if I have 3 to the negative 2, we said I could call that 1 over 3 squared, or 1 to the 9th, 1 over 9. We can also give it to you like this. If I gave it to you something like 1 over 3 to the negative 2, it's in the wrong spot. The exponent is negative, the exponent is negative, so again, you just want to flip it. So that would be 3 squared, and that pops back up to 9. So basically, if you see an exponent that's negative, if it's on the top, put it on the bottom. If it's on the bottom, put it on the top, and just keep going back and forth on that, and you should be totally fine. So again, to make sure that you know what's going on, here are 8 practice problems. I recommend that you pause the video, try to work these out, and see how far you can get. If you get stuck, that's okay. Remember, that's the whole point of learning, is you're like, I don't know what I'm doing, and then you go and you get more help, and that's kind of what we're going to do here over and over again. So get used to it. It's important. Put hair in your chest. I don't know. It's good. Anyway, so work through these, pause the video, and then we'll come back and solve them. As a hint, if you need a hint, if you've paused it and then realized you didn't know what to do, here's a hint. For stuff like this, you're just going to use the, the product rule to solve, and then you're going to simplify from there. So if the exponent is positive, you leave where it is. If the exponent is negative, you move it to the bottom. So for these, and then for these, you'd use the quotient rule. And again, once you get the answers, then you're going to simplify. Okay, so for real now, it's actually time to pause the video and give these a shot. So let's pretend you did that. All right. So first of all, we have negative 5 to the negative 3. We started off kind of ugly, I'm sorry. So remember that the negative 3 here, the negative 3 up at the top, that means that we want to take whatever it is that the rest of it is and throw it on the bottom. So the negative 3 on top means that we're going to go negative 5 to the third. Writing is really important because those 3's can get confusing. All right, so negative 5 to the third. So that's 1 over negative 5 times negative 5 times negative 5. So that's going to be negative 5 times negative 5 is positive 25 times negative 5. And if you're super good at math, hopefully you'll know that that's negative 1 over 125. Let's scoot that over a little bit. So 25 times negative 5 is negative 1 over 125, like that. So if you got that, good job, because we kind of start off with a little kick in the teeth. Like, you're feeling confident? Let's see what we can do about that. Now this one, doesn't matter what's inside as long as the inside isn't 0. It's raised to the power of 0, so that answer is just a big happy 1. Yay, happy 1. All right, 3 to the negative 4, we're going to write as 1 over 3 to the 4. So the power of 4. So again, that's going to be 3 times 3 times 3 times 3. So I'm going to combine that to 9 times 9, 1 over 81. Right? 2 to the negative 5. Now the negative's on the bottom. The negative's on the bottom this time, so it means we got to flip it to the top. So wherever the negative exponent appears, throw it the other direction. So now we have a whole bunch of these, and I think we've established in this video already that all of that makes 32. And again, you can work that out independently if you want. All right, here we are adding them together. So negative 5 plus 7. Like, well, isn't that subtraction? Well, yeah. So I'll show you. So one way to do it is we could actually say, okay, negative 5 plus 7 is equal to x squared. All right, another way you could have written it is you could have said, well, this thing is negative, so it goes on the bottom. So you actually could have also rewritten it like this, is to say x to the 7th over x to the 5th. would have given you x to the 7 minus 5, which still gives you x squared. So you're going to get the same answer either way because math is amazing. All right, so x to the negative 8 times x cubed. So we have x to the negative 8 plus 3. So that's x to the negative 5, also known as 1 over x to the 5th. Gosh, my 5s are ugly. All right. And again, another way you could have done it is you could have said, well, that x to the negative 8 means that thing goes on the bottom and the x cubed stays on top. So we've got x to the 3 minus 8, still giving us x to the negative 5, still means 1 over x to the 5th. So either way that you solve it, as long as it made sense and you got the right answer and you could do it again later if you had to, you're in good shape. All right, x to the 4th over x to the 10. So because it's a quotient rule, we're going to subtract x to the 4 minus 10, x to the negative 6, 1 over x to the 6th. Now you didn't have to solve it this way, but if you're freaking out and you really like, oh, I'm not feeling good about this, you could have just written these out. So you could have gone 4x's on the top, 10x's on the bottom, 5, 6, 7, 8, 9, 10, that's a lot. 10x's on the bottom. Come here, girl. And canceled 1, 2, 3, 4 of them out and been left with 6 on the bottom. So you could have just straight up done that as 1 over x to the 6th. And that could have worked too. Okay, so again, there's a lot of different ways to think about these problems. So I should say this multiple times. If the way I'm explaining it doesn't make any sense, it's not like I'm the only person on YouTube who's ever recorded a video about algebra. There's a billion other, well, not maybe a billion, but there's thousands, tens of thousands of other videos, and somebody just might say something in some way that just connects with you and you go, oh yeah, that makes so much more sense. So definitely, you know, look for lots and lots of options to learn this material. This one, if it kind of threw you and you're like, I'm not sure it's right, that's okay because it was kind of intended that way. So this one you would simplify, I would probably simplify the top first. So I have x to the 3 plus 6 over x to the 9, so that's x to the 9 over x to the 9. Now I got the quotient rule, x to the 9 minus 9, also known as x to the 0, also known as 1. So you could work it out that way, but understandably, that problem could get confusing and you could start to doubt yourself. So again, you can always go back to like the standard thing of x cubed, and then I've got 1, 2, 3, 4, 5, 6, and then I've got 9, 2, 3, 4, 6, 7, 8, 9 on the bottom, and they all end up canceling out. And if you get freaked out if you cancel them all out, and you're like, is that 0? It's not, but don't cancel them all out. Just say x over x. And you're like, x over x, what do I do with x over x? And you say, oh, well, what if x was 3? What if I had 3 over 3? Oh, well, 3 over 3 is 1, so x over x must be 1. So there's all kinds of ways to kind of talk yourself through this and try to find the logical conclusion if the thing that you're supposed to be learning fails you. Like if it just doesn't make sense and you can't recall at the time, try using some kind of problem solving. I mean, if you're not sure what to do on a test and you've got 30 minutes left, just spend 30 minutes coming up with some other kind of way to try to think about the problem and see if you can figure it out. That'll be fun.